Okay, I'm going to be recording the solution to a WebAssign problem. It is currently our number 19 with a clerk moving a box of cans down an aisle by pulling on a strap attached to the box. The clerk pulls with a force of 179 newtons at an angle of 31 degrees from the horizontal. So this is my 179 newtons. The box has a mass of 36 kilograms, and the coefficient of friction, kinetic friction, between the box and the floor is 0.45. We need to find the acceleration of the box. So let's go ahead and label our forces and think of it in terms of vertical and horizontal. So we have the normal force because there's a surface, and we have force of gravity downward. The force of gravity, when we take 36 times 9.8, we get negative 353 newtons. I'm going to round to the nearest whole newton. We have force of kinetic friction to the left. And then because this is on an angle, this sort of makes it a little bit more confusing, but we have to have this applied force. We're going to break it up into components. This is my component along the x, and this is my component along the y. So that's our free body diagram. Let's go ahead, and we know that since we're dealing with unbalanced forces here, it's accelerating. F net is equaling ma. We have the mass. We're going to be solving for A, but we have to figure out the whole problem, the net forces taking place on this object. So let's talk about the net forces vertically and then horizontally. Vertically, we have force of gravity, we have the normal, but we also have, there's a little upward force that is balancing out the force of gravity that coming from this FA, I'm going to call it Y. So that would be my force of gravity plus Fn plus my FAY, which means I'm just going to have to break this up into components. So let's go ahead and mark that in blue. Okay, so those are my vertical forces. Right now we know F of G, which is negative 352. We're going to say 353. We don't know F of n, but we can figure this out with a little trigonometry. That's 31 degrees. My F of AY will be sine of 31 degrees equals FAY over 179, which is 84. So this is equal to 84. Make sure you put a negative there because that is a downward force, say F of G. These are both upward forces. Okay, and then if we go ahead to horizontally, we have our force of friction this way, and we also have this one here. We don't need to use this since we have broken that up into components. So horizontally, I have a negative, again, just like that downward force here, this is a leftward force of kinetic friction, and my FAX. When I get my FAX, I would say cosine of 31 degrees is equal to FAX over 179, which comes out to be 158. So FAX, my force of friction, is equal to that F net horizontally and then F net up here vertically. Okay, well, what do we know about the vertical forces? What's happening to this box? It's actually accelerating to the right. So vertically speaking, this sum should be 0. So now I can solve for Fn and say Fn is equal to 353 minus 84. So when we calculate that out, 353 minus 84, we get 269 newtons F net vertically. For my F N. And that's a big deal because going back here, I have coefficient of friction. So I know that from what we just did, force of friction divided by my Fn is going to give me that number there. So now I have these two and I could figure out that force of friction. So let's go ahead and do that first and go back and plug that in. Equals mu. My force of friction would be a great thing to solve for here because then I can figure out my horizontal force, which is where that acceleration is. So divide it by the Fn that I just calculated equals 0.45. To solve for that force of friction, what I need to do is multiply 269 times 0.45, and we get 121.05 newtons negative because it's going against that applied force. And so now I can come up here and plug this number in to this value. So my F net horizontally is equal to negative 121.05 plus 158. I could chop that off at 121. So F net horizontally is 121 negative plus 158, and I get 37 newtons. So now I can say, all right, those are my net forces. My vertical are 0, but horizontally speaking, I do have a net. So 37 newtons equals the mass times the acceleration. Well, that looks like my acceleration is going to be pretty darn close to 1.0 meters per second squared. And that's how we use, that's how we use this free body diagram, break it up into vertical and horizontal components, use our force of friction, or solve for a force of friction knowing the coefficient of friction given in the problem, and then solving for it. I hope this helps.